Here's a wild thought I can't stop thinking about. What if Earth had rings, like Saturn? Not metaphorical ones, real glowing rings of ice and dust, arching across the sky like a cosmic crown. Imagine looking up from New York, and instead of planes and pigeons, you see streaks of shimmering light stretching from horizon to horizon. No telescope, no filters, just raw planetary bling. But what would that actually do to us, to our weather, to the stars we track, to space exploration, animals, or life on Earth itself? Let's mess with some physics, disrupt a few ecosystems, and find out. Saturn's rings are about 174,000 miles wide, but only around 100 meters thick, made of icy rock and dust particles that orbit like a cosmic racetrack. If Earth had similar rings scaled to its size, they'd likely stretch from about 4,000 to 12,000 miles above Earth's surface. But why don't Earth's rings clump together and form another moon? And why don't they just fall back down to Earth? Here's how it works. These ring particles are moving fast, tens of thousands of miles per hour. And that speed creates a balancing act. Gravity pulls them toward Earth, but their motion keeps them in orbit. It's the same reason the moon doesn't fall. Now, normally if particles are in orbit, they could come together over time and form a moon. But in this case, they're too close. In this region, Earth's gravity pulls harder on one side of an object than the other, and that stretching force, called a tidal force, tears things apart. This zone is called the Roche limit, and for Earth it starts around 6,000 miles up. Inside that range, no large object can survive long enough to become a moon, so the particles stay scattered. Not falling, not forming, just stuck in orbit, forever caught in the middle. Okay, now what will we actually see? From the equator, probably just a thin bright line, edge on, barely visible. But from mid-latitudes like New York, Paris, or Tokyo, you'd see massive arcs across the sky, day and night. Different parts of the world would get different views. Some regions might even experience partial ring shadows, depending on the season and sunlight angle. But those shadows have serious consequences. According to Cornell simulations, parts of the tropics could cool by 5 to 10 degrees Celsius, enough to shift weather patterns, monsoon cycles, and growing seasons. That much shadow also means reduced sunlight for plants. Less light equals less photosynthesis. Less photosynthesis equals less oxygen production, especially from ocean phytoplankton, which currently generate over 50% of Earth's oxygen. And then there's the impact on animals and ecosystems. Bird migrations rely on starlight navigation, which would now be partially blocked or distorted by bright rings. Insects and animals would experience permanent ambient light, throwing off hunting, sleeping, and mating patterns. Entire food chains could destabilize, not just because of light, but because the plants and water systems they depend on would change too. Now, let's talk tech. Those rings would sit right in low Earth orbit, where thousands of satellites currently operate. GPS, Starlink, Earth monitoring, telecoms, you name it. Launching new satellites becomes like threading a needle through a moving debris field, with objects traveling at 6 miles per second. Communications satellites would face constant risk. The International Space Station would need a new trajectory or reinforced shielding. But it doesn't stop there. Space exploration as we know it would be deeply affected. Rocket launches from ring-covered latitudes would become risky or outright impossible. We'd have to build launch sites closer to the poles, like Norway or Patagonia, to safely bypass the ring plane. And any mission to the moon or Mars or beyond, it would need to carefully time launches to avoid collisions or fly through gaps in the ring system, if they even exist. Exploring space becomes a logistical nightmare, or worse, a luxury few nations can afford. Ancient cultures would have worshipped them. We'd have monuments aligned to their shadows. Modern cities would brag about ring views instead of skylines, and astrology, probably even more confusing. But here's the kicker. Rings don't last forever. Saturn's rings are slowly vanishing, losing tons of material per second. Earth's would decay too. Eventually, fragments would fall, burning up in the atmosphere, or surviving re-entry and slamming into the surface at 17,400 miles per hour. Even a chunk the size of a microwave could level a city. Final thought. If Earth had rings like Saturn, our skies would be brighter. Our weather would be colder. Our tech, riskier. Our biology, changed forever. And the idea of space exploration, still possible, but a lot more dangerous. Because sometimes the things that make a planet look beautiful make it a lot harder to live on.